Broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, good morning, good evening. This is Hemant. I hope you all should be able to hear me, and also I am sharing my screen. So I hope you should be able to see my screen as well. So, friends, I would firstly like to thank you all to join this webinar organized by Cognixia. And I think most of you would know it already that today's webinar is going to all about data science. Basically, we are going to understand the world of data science. Okay, so having said that, I would like to start with the webinar. I hope am audible enough and you can hear me properly. Okay, thank you. So perfect for your quick confirmation, and let us proceed with the webinar. So first of all, let us have a very quick understanding about the Cognixia. So Cognixia is, the award-winning arm of international organization, MNC organization Collabera. Cognixia has delivered training in more than 37 countries across the globe with more than 1 million professionals trained worldwide, more than 450 clients, corporate clients across the globe with 4,500 and more trainers, and best in class training and on emerging technologies in emerging areas. Cognixia has won plenty of awards, plenty of globally recognized awards, as you can see on my screen. And also, Cognixia is the authorized training partner for some of the globally recognized organizations and corporate houses, including Red Hat, Mapr, Microsoft, Pivotal, Dell, and so on. So, having said that, let us come to the agenda of today's session. What we are going to learn in today's session. So, starting with the understanding of data science, we are going to proceed further and understand what exactly happens when we are going to work on a data science project. Okay, so I'm going to start with a very basic and very elementary question. What is data science? I will make you very comfortable with the definition of data science, with the scope of data science, by covering some of the more relevant questions like what is the need of data science? Why do we want to, have the projects, or why do we actually perform something with the help of data science? Why it is so important? Followed by that, we will try to understand what does a data scientist do in his or her day to day day-to-day job. Okay, what are the tasks, what are the activities he performs, he works on while working on a data science project. Ultimately, we will talk about the technology, how to implement, how to work on data science, because data science is not a tech, I would say, a technology. It's a whole new world, it's a whole new area. So how can we use Python, and why Python is so much important to work on data science? Followed by that, the most important questions for the beginners and the aspirants: what exactly do I need to learn? There is a lot of confusion about the technologies, about the tools, about the things, algorithms, and all. So I would help you with that particular question in quite detail, what exactly you will have to start with. And ultimately, we are also going to cover a very quick case study and end to end very small case study to build a predictive model from scratch using Python, so that you can have a very good understanding exactly how a typical data science or machine learning project is executed. Okay, I would also like to share with you, like, this particular entire webinar is going to take around 1 hour and 30 minutes, out of which the initial 1 hour or something will be used by me to explain all these things and to cover the case study. And after that, in the last 30 minutes, we are going to take care of all the questions, okay, that you all will be asking. So I would like to make a very quick a request to all of you. Okay, rather than you post all your questions during the sessions, and I might not be able to answer those questions, otherwise it will break the links and we might not be able to cover the things with the speed and with the with all the flow. So what we can do is, please keep your questions ready. Maybe you can note them down, and at the end of the session you can just start throwing your questions during the Q&A round. Okay, I hope you won't mind that. So let us go ahead and start with the session. Okay, so starting with the very first question of today's webinar, what is data science? Okay, so let us try to understand what is data science. So I will start with very typical, very standard definition of data science, but then I will try to explain it in all the with all the simplicity so that you can understand it very well. And why it is important, because when I was taking many interviews, I always find this particular problem with all the newcomers, all the beginners, that they exactly don't know what they are trying to get into. They exactly don't know what is data science, but yes, they have already started working on data science, they have already started working on machine learning and all. That's why it is pretty important to understand firstly what we are going to learn here. Okay, so let us start with the definition of data science. Data science, also known as data driven science, is an interdisciplinary field about the scientific methods, processes, systems to extract the knowledge or insights from the data present in various formats, either structured or unstructured. I hope, friends, you all must have come across similar definitions earlier, but let us try to understand this definition with little bit examples. Okay, so see, in data science, the central entity is definitely data. We have data everywhere. We have business data, we have personal data, we have corporate data, we have IoT data, we have industrial data. So we have data everywhere, so we are not going to talk about that. Okay, what is data and why data? But let us try to understand, what do we do with these data? Why data is that much important? Why data is considered as the new oil of 21st century? So the importance about data is, data is the evidence of the business. Data is the most important output of the business. Data has got all the pattern, all the observations related to the business. So data is directly associated with the business. Whatever business is doing, whatever organizations, corporate houses they are doing, that is represented by data. Now, if we have a lot of data available about our business, about our organization, using that data, we can actually understand that pattern. We can actually understand the essence of our business in a much better way. And that can open a number of gates of opportunities for our business, for our organization. So data has got a lot of things hidden about your business, about your organization. That is the reason organizations they simply cannot let the data go. Okay, if like sometimes people ask me this question, okay, why it is important to analyze the data? We have historical data, we should get rid of that. Why we are not purging the data? Why do we want to analyze that data always? So the thing is, data has got the insight. Data is not the your historical data is not only the historical data. It has got some very important pattern, trend present in that. If you can decode that, then you can not only take some actions in present to get the benefits for your organization, but also utilizing those patterns, or utilizing those trends. By utilizing those trends, you can also make some actions, make some decision about the future of your organization. That is why the prediction, and that is why the predictive analytics, is important and is referred whenever we talk about the data science. Okay, so coming back to the definition, so data science is definitely data driven science. We have data as the central entity over here. What about the science? So data science, friend, is not only about making the prediction, making the forecasting, like most of the beginners think. But if you are going to apply any scientific method present in any format, maybe you can apply some algorithm from mathematics or statistics, maybe you will apply some programming language like R or Python, maybe you will use some computer like your desktop, your laptop, maybe supercomputer, GPU based computer, maybe you will apply some hypothesis, some techniques from statistical, from inferential statistics, or from EDA related techniques like visualizations. Basically, science can be present in any format. And if you are going to apply the scientific methods present in any format, and you are using these platforms to extract the insight present in the data, that is nothing but data science. So data science is nothing but when you combine data and science present in any format to extract the insight. Now, there is also one important question: what is insight? What do we understand by insights? So friends, there is a very important thing to understand related to traditional analytics and data science, or traditional business intelligence and data science. So see, business intelligence is also going to do the similar thing, but it is way different than data science. In business intelligence, you take the data, you apply mostly some visualizations to understand the current pattern or current trend present in the data. We call this descriptive statistics or descriptive analytics. Okay, so when you are using your data and you are showcasing what is happening right now with the help of data, that is traditional business intelligence. Data science not only going to do that. So yes, data science is also traditional BI, data science is also descriptive analytics. But apart from that, data is also going to give you prescriptive and predictive analytics. What are prescriptive and predictive analytics? Prescriptive analytics, when you are going to use the data and suggest your organizations, your businesses, what steps you should take in order to solve certain problem, or in order to be more benefit out of your data. That is known as prescriptive analytics. You are prescribing based on your analysis you have done on the data. Second is predictive analytics. Predictive analytics is when you are utilizing the data and you are making the prediction about the future, or you are making the prediction about the unknown. So see, prediction can be of two type. Prediction is something, or prediction is like predicting something which is unknown, which is not known. Prediction not necessarily are going to be only related to future. Okay, so generally we use two words: prediction and forecasting. Prediction is knowing something or predicting something which is unknown. Forecasting is predicting the future that we don't know. Okay, so data science in short is the combination of descriptive statistics, talking about the things which are taking place, which are happening right now. Prescriptive analytics, talking about the actions you should take based on your historical trend and your pattern present in the data. Third thing is predictive analytics, so which is nothing but making the prediction about the unknowns and the future. So in short, data science is going to generate you insights. That insights can be descriptive, prescriptive, or predictive, and using that insights, definitely you can do a lot. Okay, that is going to be really really important for your business and for your organization. Okay, so that is why data is important, and that is why data science is that important. So proceeding with the next slide, need for data science. So little bit now we know, okay, what is data science and why it is important, okay. But let us try to understand why data science has suddenly become that important. So friend, data science is not something very new. Data science is there from quite a long time, in fact from decades. So initially this was known as data mining techniques, where all the statistical algorithms were used to perform the data mining, and all these things, regression, classification, all these things used to perform the statistical analysis. But at that point in time, the scope, the application was very limited. Only few sectors, only few verticals were utilizing all these things. But over the period of time, with the emergence of computational power, with the emergence of ease of doing the calculation and the computation, now data science has become available for all the organizations, maybe in all the sectors. And that is the primary reason now we can use all these expensive algorithm from computation point of view. Okay, we can train the models with tons of data and make all the predictive analytics. So that is the reason why data science has become such a boom. But let us talk about all these important pointers over here. So huge amount of data, right? So we have huge amount of data, and using the traditional analytics or using the only business intelligence, how much data we can consume? No, right? We cannot extract each and every bit of information from tons of data just using descriptive statistics. We need some more summarized way. We need some more smarter techniques to extract the insights out of this tons of data rather than analyzing everything. Data presents in different variety. So traditional analytics or BI is actually capable of analyzing and processing only structured or sometimes semi-structured data, right? When it comes about the unstructured data like image processing, audio processing, video processing, x-rays, okay, we cannot use the traditional analytics. So data science, or with the help of machine learning, we can process all this type of unstructured data along with the structured and semi structured data, of course. But yes, we can make the decision now about the unstructured data as well, like image classification, voice recognition, and speech control. These all are the very simple, very common examples of unstructured data and implementation of machine learning using unstructured data, like face recognition, person recognition, object recognition, OCR, to read the characters. So these are very common examples of machine learning or data science using unstructured data. Fast result, real time, and to near to real time analytics. So basically we have many techniques available in data science which do not require you to firstly come up with a data warehouse, a data mart, a structured approach, then apply the analytics. With the help of data science, you can actually perform mostly near to real time or real time analytics. What do we mean by real time analytics? So whatever transactions, for example, are taking place, a very common example can be when you are shopping on some online portal like Amazon. Okay, you are making the some purchases, you are adding some things to your cart, and at the same time, at that point in time itself, you are suggested the recommendations. Yeah, you are given the recommendation, like persons who have bought this blah blah item, they have also bought some other item. So this time of real recommendation, real predictions are being made nowadays. That is possible only because of data science. Okay, diagnostic, predictive, and prescriptive analytics. So this is the same thing we have talked in the last slide, so I will skip that point. Automated and intelligent analytics solution. So now with the help of DevOps, latest DevOps and the emerging DevOps techniques, data science has integrated with the DevOps techniques with the help of the a fastly growing programming language like Python. You can actually not only automate the entire data processing, but also your analytics or your predictive analytics with the help of latest DevOps enhancements. So now it has become fully automated and intelligent. In fact, organizations and businesses are also exploring the options to come up with a fully automated data science workbench, where automatically the model training, monitoring, retraining, all these things can be automated in end to end way. So that is something we are going ahead with nowadays with the help of data science. Next slide is going to talk about what does typically a data scientist do. Okay, so now we understand it very well, what is data science and why it is that much important. Let us talk about what a data scientist, data analyst, machine learning engineers, they all are going to do when they work on a typical data science or machine learning project. Okay, so see friends, again there is a very big misconception among the beginners that data scientists are always going to make prediction about the future, prediction about the unknowns. No, so there is going to be a lot of other things. Okay, and actually a data scientist is supposed to work on n number of different things while working on a data science project. So let us try to understand how typically a data science project is executed in end to end manner. Okay, so firstly, like any other project, we start with identifying business problem and opportunity. Maybe in some typical IT development project, it can be the business understanding phase, or it may be like a analysis phase. Here in case of data science, there can be two possibilities. In some of the scenario, business has already got some problem, business has already got some recommendation for the data scientist, like this is the problem and we are looking for your help to come up with some data science solution and solve this problem. The second option is opportunity. So sometime business don't know, they don't know what are the opportunities available within our organization. We are pure business folks and we don't understand the technical things at all. So what they are going to do is they are going to ask the data scientist, please come, have a look at our process, have a look at the data we have, and make recommendations about the opportunities we have to implement the data science projects. Okay, so both type of scenarios are possible. Either you are going to give a problem, ready-made problem, project objective, or maybe you are supposed to find the opportunities. The second case is more probable. Okay, coming to the second point, designing the analytic solution. Once you have a problem statement defined, if it is not already there, you will start with designing the solution. As a data scientist, you will lay out the entire design, end to end design, the architecture, the flow, how you are going to solve this problem in end to end manner. Okay, so you will decide how we are going to engage the business folks, you will decide what is going to be the algorithm, the technology, the tool, the platform we are going to use, what is going to be our development strategy, deployment strategy, and all. So you are going to come up with the entire analytics solution. Data collection and integration. After that, you will start collecting your data, right? Because what is the most important thing in data science? Data. So you will start with data collection. The first technical step in a data science project is data collection. You collect the data and you start integrating the data together. What is integration? Many a times your data can come from n number of different sources, right? So it is highly possible, like your one data set is coming from a file, your another data set is coming from a relational database table, your another data is coming from some public platform, or maybe using web scraping and all. So n number of possibilities are there. So based on that, you will not only collect the data, you will develop a pipeline with the help of data engineers, of course, to integrate that data together in such a way that ultimately you can have a single snapshot of your data after all pre-processing thing applied, that we are going to talk next. Comes the data analysis. So see, as a core data scientist, as a core data analyst, you are supposed to perform the core analysis first. Okay, so here we are talking about the traditional data analysis only. We are not talking about the predictive analytics or prescriptive analytics. What is core data analytics? Core data analytics is you will make yourself comfortable with your data. Here you will perform a lot of analysis like univariate analysis to understand the distribution of various data, various variables, features you are going to have. You will perform some sort of like outlier analysis. You will understand, the bivariate analysis, the relationships you have for given set of variables, two features, independent variable, dependent variable. You will perform multivariate analysis to understand the impact, to understand the pattern present in the data. So a lot of core data analytics techniques you are going to use, firstly to make yourself comfortable with the data and the business. So see, core data analytics is not about understanding the data. It is understanding the data with the help of business, understanding the business, sorry, with the help of data. So that is what do we do as a core data analysis. Followed by that, we come to data engineering step, which is data cleaning, processing and transformation. Generally we also call it ETL, or data processing pipeline development. So what is data cleaning, processing and transformation? Basically, when you are going to get the raw data from n number of different sources, possibilities are going to be there. Your data is not present in the adequate format. You are going to suffer from a lot of missing data, corrupt data, outlier data, and a lot of things. So you will have to firstly apply all sort of ETL techniques. ETL is extract, transform and load. Okay, so basically where we are going to nothing but process our data, clean our data, and in aggregate. Many a times you perform data aggregation. We do a lot of things, so on the data, on the raw data, and ultimately we make the data available in the format so that this data can be utilized by our predictive analytics solution that we are going to develop in future. Okay, so that is what do we do in this particular step. Followed by that, we are going to work on building analytical or machine learning solution. Once you have the data available with you, you have processed that data, you have transformed that data. Now you can apply the analytical or machine learning solution at the top of it. And in rough language, we also call it like machine learning model development or training or testing or validation. So all those things are going to take place in this particular step. Finally comes the deployment, monitoring and support planning. So what do we do once the model is ready? What do we do once the predictive solution is ready? We deploy that solution in the production. We deploy that solution so that the live and the production data can be feed as input to your model, and you can make the predictions for the live coming incoming data in the production environment. As a data scientist, you also plan the monitoring and the support of your predictive solutions, how regular you are supposed to revise your model, how regular maybe retraining is required, how the support in different sort of failure going to be provided to the model, to the analytic solution, how the results are going to be consumed by the business. So all these things are going to be there in the deployment, monitoring and support planning. Okay, so friends, before I proceed further, I am going to launch a very quick poll. So you can actually start contributing to that particular poll. So that would be very helpful for us to understand your requirement, to understand your thoughts, your thinking about the data science in your future. Okay, so thanks for that. Okay, perfect. So let us proceed further and talk about the next slide. So the next slide is Python for data science. Okay, so far we have been talking about data science. What is data science? What do we do while working on a data science project? How a data science project is executed? Now let us specifically talk about the implementation part. How machine learning is implemented, how a data science project typically is implemented. Okay, so here comes Python. the importance of Python. So why Python, why not other programming languages? Okay, so yes, there are many programming languages available. So there are many programming languages available, and you out of all these programming languages, we generally prefer Python. So let us try to understand, why Python is superior than other programming languages. Okay, so I think most of you would be already aware of it. Like, we have R, we have SAS, we have Python, we have, many other programming languages which are used for data science or machine learning project implementation. Out of all these programming languages, why Python is superior? In order to understand that, let us try to understand all these, pros and cons of Python we have. So Python actually is a one-stop solution for all sort of data science needs. Okay, how? Let us try to understand that. First of all, easy and efficient data extraction, manipulation, and transformation. Okay, so as we learned in the last slide, when you are going to start with any data science project, you are supposed to start with data collection, data cleaning, data integration, data preprocessing. We need a platform, we need a programming language using which you can perform all this type of data engineering work. Python has got all the important data structures, including NumPy array, Pandas data frame, core data structures like list, dictionary, tuples. These are going to provide all sort of, operations, functionalities that you are going to need for any sort of data engineering and data preprocessing stuff. Specially designed data structures for multi-dimensional array computation. So as I was mentioning earlier, NumPy array is the, array implementation in Python for all sort of one dimensional, two dimensional, n dimensional array data processing and computation. So using NumPy array, you can not only perform, traditional matrix or array computation, but also you can process all sort of images, you can process the audio signals, video signals, convert them into the array format, and apply all the mathematical and statistical techniques at the top of that. Okay, so we have got all sort of important data structures which are not only needed for structured data but also for unstructured data. Great machine learning libraries, scikit-learn is quite famous. Apart from scikit-learn, we have got plenty of packages available in Python to implement all sort of important machine learning as well as deep learning, computer vision related techniques. So it has got great library, and this library is, getting evolved. This library is, kind of expanding exponentially every day. We have got a lot of, a very good community, online community of contributors across the globe, which are who are contributing day and night to this community. And this library, this, platform is growing like no other platform. Advanced data exploration and visualization library. So as I mentioned earlier, data science is also descriptive statistics, descriptive analytics, where we also perform all sort of, traditional data analysis using exploratory data analysis. We draw a lot of plenty type of plots, charts, visualization. So Python has also got some of the very cool, some of the very flexible data visualization libraries, including matplotlib, seaborn, plotly. Plotly can also be integrated with Python. So Python has got, matplotlib and and seaborn. These are the packages, these are the libraries which using which you can actually come up with any sort of visualization, custom visualization. With the help of plotly, you can also come up with the 3D and interactive visualization. So yes, we have got very good libraries for descriptive or, visualization based analysis. Then we have got the APIs to support big data integration. So very important part of Python, as compared to other programming language, it has got great compatibility, it has got great integration or connect with the external world, external tools. Maybe it can be simply a relational database system, or it can be a big data environment. Python can be integrated with all sort of tech stack very easily. Okay, so it has got great communication, it has got great connection with all the external world. In fact, in the big data environment, generally we use Spark as the statistical programming language to implement the machine learning models, and Python is the language which is nowadays quite familiar among the Spark developers as well. We call it PySpark, so that you can actually build the predictive models using Python, but utilizing behind the scene, utilizing the Spark engine. So Python is everywhere. Advanced deep learning packages, yes, this is also one of the very important reason where even our programmers or data scientists who used to work on R, they are switching from R to Python, because all the latest enhancements, all the latest development is going on using Python, whether it is Keras implementation, TensorFlow, PyTorch. A lot of frameworks are there which are primarily released for Python. Okay, and that is the reason where other statistical programming languages or platforms lagging behind. So it has got great library, great engines, great frameworks for deep learning projects, basically to process the unstructured data. Easy application development and deployment. And yes, finally, once you have everything ready, okay, you have the your model trend, you have got the predictive solution ready, what you are going to do next, you are going to utilize it, right? You want to deploy that. So Python has got the great deployment capabilities like Flask. Flask is one of the very popular package, or one of the very popular platform using which you can convert your analytic solution into an API, and you can make that API available to the external world, to the users, to utilize your model. So the expectation from a statistical programming language is not only to provide you all the functionalities using which you can come up with the solution, but also you should be able to consume that solution. So that is why application development and deployment is that much important, and Python has got great capabilities for that. Okay, so these are some of the very strong points where Python is really leading ahead. And now we can talk about the first the last, sorry, important slide, which is what exactly do I need to learn, okay, as a beginner. So there are a lot of things. Okay, so like Python is just one thing, and there is a very big confusion among the aspirants. Okay, I am supposed to learn Python, but exactly what am I supposed to learn? Am I supposed to learn some theoretical things before I learn Python, or how should be my journey in the fields of data science, right? So that is a very big question. That is a very big confusion among the aspirants. So let us talk about that particular question. So starting with the data engineering and data preprocessing. So yes, the first expectation from you would be performing data engineering and data pre-processing related stuff on the data. So you should be comfortable with all sort of data cleaning and data pre-processing related aspects. Okay, so you need a programming language like Python. Okay, yeah, by using Python, basically you can perform all this type of stuff, but you will have to learn, okay, before you simply jump to the machine learning model development and all. Firstly, you should know how can I get the data, pre-process the data, clean the data, aggregate the data, all sort of data engineering thing. How can I do that using Python? So that is the first expectation. Second is the data data analysis. Yes, before coming to the predictive analytics, firstly you should learn how descriptive analytics is important and how do we perform our analysis using visualization, using some core descriptive analytics techniques, right? So as I was talking about earlier, what is the distribution analysis, probability distribution analysis, correlation analysis, all these things are very important and these are expected from a data scientist. Next comes the statistics and probability. Yes, so many folks ask me this question: how can I learn statistics? What is statistics important? Can I skip statistics? Can I skip probability? Can I skip mathematics to learn data science? Okay, the answer is no. Statistics and probability is the core essence of data science, because the entire statistical modeling techniques, okay, they are actually based at the top of statistics and probability. Even if you are going to start with a very simple model like regression or logistic regression, we have statistics everywhere. You will have to follow all the rules of statistics. If you are not going to follow all these concepts, you can work on a model at very small scale, maybe a simple project, but when you are going to actually work on a real scale project, all those things are not going to work. Okay, so you will have to understand the essence of statistics and probability. That is very important. So inferential statistics, descriptive statistics, that is really really important. You should know all these basic concepts of statistics and probability, and they are going to be quite useful when you are actually going to work in a real time project. Next comes the data visualization. So data visualization is nothing but performing the descriptive analytics. Yes, you are also supposed to be comfortable with all type of charts and plots. How do we perform univariate analysis? How do we perform bivariate analysis, multivariate analysis? When do we use scatter plot? When do we use histogram plot? When do we use area plot? When do we use line plot, box plot? So yes, different variety of plots are there, variety of charts are there. What type of plot is used in what type of scenario, and how to utilize these or how to draw these charts using matplotlib, using plotly, seaborn. So this is also one expectation. Next one is machine learning. Machine learning comes at the very end. So now once you know your data very well, you understand the requirement very well, you analyzed your data statistically, then you come up with the statistical model. You explore all the possible statistical algorithms and the model, and you select the most relevant and most feasible approach, feasible algorithm for your use case, and then you proceed further with the machine learning model development and training. Okay, so this is what exactly you are supposed to learn as a beginner. Okay, this is, I would say, the mandatory list of the things that you are supposed to learn in order to get into data science, and all of these things are really really important. You should not skip any of these. Okay, in fact you should start your journey in this particular order itself. Okay, so don't hurry to come to machine learning. I know it is quite interesting, it is quite fascinating, but you should actually start your journey in this way, in this order only. Okay, get yourself comfortable with the data pre-processing, playing with the data, analyzing the data, understanding the data, representing the data, making inference out of the data, visualizing the data, and then predicting the data. Okay, so that is the recommended order. So here I would like to conclude the theoretical part of this webinar, and now I would like to quickly jump to the very simple end-to-end case study for this particular demo. And what we are going to do in this case study, we are going to implement a very simple classification model, which is k nearest neighbor classifier, to solve a simple classification case study. Okay, what is this case study and how we are going to solve that case study? I'm going to come to that next. But before that, let us understand the k nearest neighbor classifier in little bit detail. Okay, what is k nearest neighbor classifier? As you can see on my screen, k nearest neighbor classifier is a classification algorithm. It's a non-parametric classification algorithm, and using this k nearest neighbor classifier, basically we make the decision about the class, about the type of the objects or your data points. For example, as you can see on my screen, there are two type of data points present. Some of the data points are blue circle and some of the data points are red triangle. We can say that all the blue data points are class 1 object, all the red triangles are class 2 object. Then we have some data points which are like rectangular, right? Yellow or orange rectangular. These are those data points, friend, for which we don't know the classification type. So there are only two possible classification, class A, class B. So we are supposed to classify these rectangular data points into either class A or class B. So let us try to understand how k nearest neighbor algorithm is going to find the solution in this particular situation. Okay, this is a very simple scatter plot that we have plotted here on two most important features. For example, feature 1 on x-axis and feature 2 on y-axis. Once you have this type of scatter plot, the k nearest neighbor algorithm is going to work on the majority vote concept. So what it is going to do, for example, if this is the data point for which we don't know the classification type, we will firstly select k nearest neighbor to this particular data point. So we use some techniques in order to decide what should be the k value. But for instance, suppose if our k value is 3, so we will select 3 nearest neighbor for the given data point. For this particular data point, my 3 nearest neighbor are this one, and this one. And for all these 3 data points, the classification type is blue circle, which is class 1. So class 1 object, class 1 object, class 1 object. So the classification type for this particular data point will also be class 1 object. A very simple, a very basic algorithm, but yet very useful. Okay, very similarly, let us understand what will be the classification type of this particular object. So this particular object is surrounded by 3 neighbors, this one, and this one. Out of these 3 neighbor, the majority classification type is red triangle. So what would be the classification type of this data point? Red triangle or class 2. Okay, so this is the concept, this is the core concept behind k nearest neighbor algorithm. Now I would like to very quickly switch to my spider window, using which I can show you an end-to-end case study. Okay, so I hope you should be able to see my spider window, and let me make my fonts little bit more visible to you. Okay, so now we are going to start with uploading the training data or getting the data. Like the first step to start any particular project or case study, you collect your data. So I'm going to utilize some Python libraries, and one such important libraries is pandas data frame, using which actually you can collect the data, you can actually analyze, understand, and import the data in the form of tabular type of structure. Okay, we call it data frame basically in the language of statistical programming languages. So I have actually I am actually collecting my data from a file using this pandas read csv function, and as you can see, my data frame has been imported. Let us try to understand what is given here in my data set. So friend, this data set is actually diabetes data set. This data set has been collected for all the diabetic patients, and basically here we have got all the independent variable or features, starting from the attribute like pregnancy, glucose, blood pressure, skin thickness, insulin, bmi, diabetes function, age, and outcome. So all these are some sort of independent variables. Okay, from starting from pregnancy up to age, these are our independent variables or features. Outcome is our target variable. So basically, here we are going to perform a classification, or we are going to build a classification model which can predict the type of diabetes. So diabetes generally can be classified into two categories, type 1 and type 2 diabetes. So here actually we are having the same column, outcome. 0 is type 1 diabetes, 1 is type 2 diabetes. Using this data set, we have to come up with a predictive model which can take all these attributes starting from pregnancies up to age as independent variable as input, and it can make the prediction about the type of diabetes. Okay, so this is the expectation from this particular case study. So let us see how we are going to proceed further. So some of you might be aware of this concept that when you are going to work on a supervised machine learning model or approach, you are supposed to divide your data into training set and test set. Using training set, you train your model. Using test or validation set, you test or validate your model. And that is the important part, because you cannot simply test your model using the training data, because training data is the known data to your model. Okay, so for that particular purpose, we have got our entire data set present in the form of single data frame. So we will split this data set and we will come up with the training data set and test data set. Okay, so I am going to import one library which is coming from scikit-learn. I am going to import a function basically, which is train test split function, which is coming from the scikit-learn package and model selection module. So here I have imported this particular function. This particular function is a very simple function. To this function, trend test split function, you are supposed to provide the set of independent variables and dependent variables separately. In our data frame data, we have got everything in just one data frame, all the independent variables and the outcome, the target variable. What we are going to do before we apply this function, using pandas data frame iLook method, I am going to collect all the independent variables in one data frame and our target variable, which is outcome, in another data frame. Okay, I'm calling this data X and data Y. What is data X? Data X is nothing but the collection of all the independent variable starting from pregnancies up to age. Cool. We have got our set of independent variable. What is data Y? Data Y is nothing but our dependent variable or target variable, outcome. Okay. So here we have only one attribute, outcome. Once you have split your data set vertically into set of independent variables and a dependent variable, you can actually call the trend test split method. Trend test split method will take this data X and data Y as input and a ratio into which you want to divide your data into training set and test set. Generally, we use 20%, 25%, or 30%. Okay, this ratio, which is nothing but like 30% records will be split to for testing purpose and remaining 70% records will be kept for training purpose. Okay, it's a ratio between training and test data split. Random state actually to initialize your random seed, because it is a random operation. So how the split should be done, that is going to be controlled by your random state. Okay, so now we are going to call this function, and this function is going to return me four things. I have provided data X and data Y as input. This will return me xtrain, xtest, ytrain, ytest. Xtrain is nothing but it has divided the data X horizontally into two parts. 30% records for all the independent variables for testing purpose, 70% records for all the independent variable for training purpose, and very similarly 30% records for the target variable for testing purpose, and 30% 70% records for training purpose. Okay, so when I am going to see my xtrain has got all the independent variable, but this is available for 537 records for training. X test all the independent variable, 8 variable for 231 records for testing purpose, and your y test and y train 231 but only one variable, 537 records, only one variable. Okay, so in that way we have performed the split. What is next? So now you have you have got your training data set, you have got your test data set. Next is nothing but performing the feature selection. And basically feature selection is nothing but an approach using which you decide which features are important, which features are not important. It is a very important aspect of any machine learning model development. And because we don't have enough time to talk about all the feature selection approaches and methods that we generally use here, simply I will select all the features to implement our model. But what I'm going to do, I'm going to very quickly suggest one of the very typical approach that we follow to perform this analysis, and that approach is known as correlation analysis. In Python, with the help of pandas data frame, you can very easily come up with a correlation matrix. So basically, if your data is present in any pandas data frame object like data, you can call the correlation function CORR, and this is going to return you a correlation matrix for all your independent and dependent variable. So my correlation matrix CR is ready. If I see, okay, this is nothing but a kind of cross step tables where I have all the columns, all the features present in the column and all the features present as the row as well. This is going to give you the correlation matrix, which is the Pearson R coefficient value for each and every pair of independent and dependent variable. But we are not interested in this entire matrix. We are going to be interested only in the correlation of dependent variable outcome with other independent variable. And here we have got that list. So basically this particular dependent variable outcome has got some some average correlation with pregnancy, which is positive 0.22. Glucose, a good correlation, good positive correlation 0.46. With other attributes like blood pressure, skin thickness and all, it has got very poor correlation like 6%, 7%, 13% is at least significant. BMI 0.29%, diabetes pedigree function 0.17, age 0.23. So these are our independent variables, and it seems like none of the variable is having correlation less than 5%, which is generally considered as the threshold. So there is no harm if we select all the independent variables as the feature in our model. There is one more technique, like I was talking about the Seaborn package, and with the help of the Seaborn package, I'm going to quickly show you a very quick visualization here, which is known as the heat map plot. With the help of heat map plot, the same analysis that we have done here, you can actually perform here with the help of heat map plot. And here, as you can see, you can perform this analysis with the help of color encoding, like how your target variable outcome is correlated with all other independent variables. Okay, having said that, we are now good to go ahead and build the model. We are supposed to implement k nearest neighbor algorithm, and k nearest neighbor algorithm is present in the scikit-learn package neighbors module. And here you will import it with name k neighbors classifier. Okay, so let us go ahead and import this function. Once this function has been imported, we can call this function by providing the k value. Okay, for example, we can keep this to initialize this k value, we can take some number like 25, because we have got enough data. So we can start with some value like 25, but ideally this particular value should be evaluated using your cross validation techniques, and you should use the proper value of k after all sort of your analysis and validation. But we can start with some value like random value like 25. Okay, for k value 25, our model has been initialized, our algorithm has been initialized. Now once you have the algorithm initialized with the name knn, I can call this method, I can call this algorithm, and perform the training that we call as model training on my training data. While performing the training, what I will do, I will simply call the fit function using the knn object, and then I will provide my training data as input. What is my training data? Set of independent variable xtrain and dependent variable ytrain. At the time of training, you are supposed to provide both of these two data sets as input, and my model has been trained already. And then Once your trained model is available, you can call the predict function on any unknown data point. Okay, so we have got test data set x test, which is the collection of independent variables only. Now we can test our model if our model is making correct predictions for these test data set, for this test record or not. So I'm calling my trend model, I'm calling the predict method basically using my trend model knn on the x test data set, and then predictions are made and predictions are available in the variable ypred, and here we have got all the predictions. So basically we were supposed to decide the target variable outcome, whether the given record should be a type 1 diabetes or type 2 diabetes, and here we have got the predictions already available for all the test records. But how can we verify if the predictions made by my model are correct or not? So basically what I am going to do, friend, here I am going to collect the original labels of the test data set that I did not provide to my model and the predictions made by my model. I will take these two things together and I will create a result data frame. Okay, so that I can have a sort of side by side comparison. And here you are. As you can see, for this particular record, the actual value of diabetes type was 0, predicted is also 0. 0 0 1 1 0 0 0 0 1 1 1 1 1 0. There is one misclassification, right? Then 1 1 0 0 0 0 1 1 0 0 0 0. It seems my model is doing great job, and the accuracy is also looking quite good, but we cannot rely on this particular manual comparison. So definitely we need some automatic, we need some evaluation matrix, right, using which we can calculate our model accuracy. So what I'm going to do, I'm going to perform two sort of model verification here. Firstly, I will perform the model evaluation using confusion matrix. Confusion matrix is a widely used a matrix for a sort binary classification model, or in fact sometimes it is also used for multi-class classification problems as well. So I'm using the confusion matrix here. Confusion matrix is going to accept your actual labels and the predictions made by the model on the test data set as input, and when you are going to execute this, it is going to return you confusion matrix. Confusion matrix is nothing but, for a binary classification problem, it is going to be a 2 by 2 matrix like this, where this first number is nothing but is known as true positives, this number is known as true negative. True positive is nothing but, friend, how many positive records were there in the test data set and how many of them were predicted as positive. So there are 133 records which are actually 0 and predicted as 0. We can call it negative or positive according to our definition. 43 records which were actually 1 and predicted by the model as 1. These are the correct predictions. Remaining 17 and 38 are the incorrect prediction on the other side. Using this confusion matrix, we can very easily calculate the accuracy by summing up the diagonal numbers and dividing it by the total number. So when I do that, I got my model accuracy as 0.7619, which seems that my model accuracy is 76%, which is really good accuracy with some of the randomly selected value of k25. So when we are going to work on model validation, this accuracy is supposed to be improved a lot. Okay, so this was just our first trial, and in our first trial itself we have got 76% accuracy. Other than that, what you can do, you can also actually work on some visualization based methods for your model inspection. Okay, something like that. Here I have got a scatter plot analysis where I am using glucose and body mass index BMI for on x-axis and y-axis to come up with this scatter plot, and I'm using our test data set actual labels and predicted labels to come up with the color of this scatter plot. You can observe two type of data points over here. Like, some of the data points are solid, where the background is blue and the circle and the center is also blue. Like, background is red and center is also red. These are the correct prediction. all the data points which are having same color in the background and in the center, they are correct predictions made by the model. On the other side, data points like this, background red center blue, or center red background blue, these are the incorrect predictions. Okay, so this type of visualization, plots, charts, we can very efficiently, we can visually we can represent the performance of the model. We can present the outcome of the model, maybe in front of the business users and non-technical users. Okay, so this is also very efficient way. And here I would like to conclude this second part of today's webinar, and simple end-to-end case study to understand the machine learning solution or machine learning method end to end. So I hope you all have enjoyed this webinar, and now I am going to answer all of your questions. Okay, so I know you have been waiting for quite long to ask your specific queries and questions, so you can now feel free to ask your questions, your queries in the chat window. I will try my best to answer as much question, as much queries as I can. Okay, and for your information, I am also going to throw out the second poll of today's session, and you actually can start contributing. You can provide your response for that second poll as well. Okay, so that would be very helpful. Okay, great. So now I'm going to start. I'm going to go back basically to my presentation, and then yeah, I would also like to share one important thing with you all. So basically, Cognixia has got an early bird discount offer for all of you. So I would like to share with you, Cognixia is planning to start its next instructor-led training on data science using Python starting from 23rd of November. So if you are going to enroll yourself for this particular batch, which is starting from 23rd of November, you can actually opt for an early bird discount, okay, which is actually flat 40% off. Okay, so make sure you if you are planning to enroll into this course, you can opt for this particular offer, and for that purpose you can connect with the Cognixia support team on the given contact, using the given contact details. So you can directly connect on call, or you can email as well. So now I can proceed further with the Q&A round. Okay, so let me start from the beginning. uh, okay. Okay, so first question is, what master degree do you recommend for someone looking to study data science in their master? So, ideally, no, the most appropriate master would be like a master of statistics. So, as I mentioned earlier as well, statistics is the core, is the essence of data science, and all the big organizations are looking forward for the candidates who have studied statistics and probability during their academics. Okay, so I would suggest master of statistics. How do I get data science internship? Okay, so data science internship nowadays is quite common and quite easily available. Many organizations are providing data science internship in the fields of data science. All you need to do is, maybe you can be little bit active on LinkedIn, and you can connect with the HRs over LinkedIn. Many organizations are offering internship in the fields of data science, specifically if you are actually going to get graduated in your future. Please host a webinar for machine learning as well. Yeah, sure, Nikhil. And actually, I have included some part of machine learning, but in future, definitely we are going to we can come up with a complete end-to-end webinar on machine learning as well. Okay. As I'm a beginner, I'm looking forward for the beginner. Thanks, Raksha, for your interest. Will you make available the presentation slide? Yes. So I think this is going to be available on the YouTube. This recording is going to be available on the YouTube or Cognixia portal. For more details, you can get in touch with Cognixia support team. Can we use Jupyter Notebook and R Studio and data science? Yes. So basically, if you are going to work on Python, and basically if you are going to work on R as well, Jupyter Notebook is going to support both the programming language. You can use Jupyter Notebook for R and Python both. And if you are going to work on R, then yes, R Studio is one of the widely used IDE used for R programming. Can you share this slide asked by Venu? Yes, I think that is going to be available on Cognixia portal. You, for more details, as I mentioned earlier, please check with the Cognixia support team. Is the data analytics and data science different? So yeah, I think I have already covered this question. So data analytics is generally nowadays, data analytics is used as a synonym of data science, but initially data analytics was the core data analytics, the core BI, as I mentioned earlier. And you can also call data analytics as descriptive analytics, but data science is like descriptive, predictive, and prescriptive analytics. So that is the minor difference. Actually, now I am working as a data analyst position and I have 1.7 years of experience. So I want to move to data science position. Please, how to crack the interview and how to move to data science? Can you explain? Thank you. Then finally, how to how to learn data science easily, asked by Maruti Prasad. And so Maruti, I think the easiest answer to this long question would be, don't escape the essence of data science, which is the core mathematics statistics, because most of the time whenever you are going to face the interviews, the interviewers are going to start with that only. Okay, so work on your foundation, work on the statistics and mathematics part, understand whatever you are doing. It is not important that you know n number of things, but whatever you know, it is important you know it completely. Exactly, what is the difference between structured and unstructured data, asked by Maruti again. So structured and unstructured data, structured data is nothing but when your data is going to be present in the form of row and columns, basically like a table, like a Excel sheet, like a CSV file, we call it structured data. Unstructured data, when your information is going to present in some other format, maybe your information can be present in sort of images like binary values, 0 1 0 1 0 1, maybe three-dimensional arrays when you have RGB, the colored images, your sound files like audio recordings, video recordings, where information is going to be stored in the form of frames. Again, the frame is going to be the collection of bits. So this type of information, this type of data is known as unstructured data, where information is not structured or arranged in the form of row and column. Okay, then Khitam is asking, is data mining a subfield of data science, or I need to know everything about data science to do data mining? So see, data mining is nothing but the statistical algorithms, the models that we call, okay, these are supposed to be the subdomain or area of data mining. So data mining has got a lot of techniques, a lot of algorithms to perform or to build statistical models, and data science is going to utilize those techniques, those algorithms, those models. So in that way, data science and data mining are quite related with each other. There are four types of data variety. One of them is quasi-structured data. I'm not sure what your question, because you were typing something and you left, Aditya. Okay, I can skip that question. Could you please detail a little bit more about the difference of forecast and prediction? Yes, David, for sure. So see, what is forecast? Forecast is something when I am going to predict the future. So for example, I have got some data set about the rain, how much rain was there in last 5 years or maybe last 10 years in some particular city of India. And based on that historical data points on rain, I want to forecast how many rain will be there in India next year. That is forecasting, when you try to predict future based on the historical value. What is prediction? Prediction is nothing but when you use the attributes, features, and independent variables to predict about some unknown thing that we call as target variable. Just like we saw in the case study, we used a number of attributes, mainly like insulin, age, BMI, and all, to decide if the given type of given diabetes is type 1 diabetes or type 2 diabetes. So type was unknown, and we used our model to make the prediction about the type using other independent variable. That is prediction. Okay. Can I build a smart AI in our studio? Aditya, I'm not sure what is your definition of smart AI. So please help me with that. Then maybe I can answer this question in a better way. What is the difference between data science, machine learning, and big data? See, data science is something that I have already explained, I think, in quite a bit detail. Machine learning can be understood as a subdomain of data science, because not all the time you are going to use machine learning and data science. Sometime you also do descriptive analytics, sometime you simply do some sort of core analysis like hypothesis testing, distribution analysis, some other parametric and non-parametric test. So it is possible that you will not use machine learning always while doing data science, but whenever you are using machine learning, actually it can be understood as a data science project. Big data, on the other side, is a platform which is used to basically store the data in a distributed manner. So that is a platform to host the data, your repository. It has nothing to do with data science. Yes, in some cases big data environment can be your source or can be the platform where you are supposed to implement data science. Okay. Okay, again, similar question, the difference between data science and machine learning. So I think I can skip that question. Then Grish is asking, can mechanical engineer get job in data science if he or she is having the experience in mechanical design engineer? I have seen, in fact, non-engineers. I have seen many other folks totally from maybe non-technical background who got into data science. So there is no as such any restriction. All you need to do is you have to be very comfortable with this entire process. All the things I have already covered in this webinar, what exactly you are supposed to learn. So only thing which is going to be evaluated at the end of the day, your knowledge. Okay, background is definitely going to matter a little, but only up to screening round. Once you have crossed that round, once you are selected after screening, then at the time of interview no one is going to be very much worried about your background. Okay, until and unless your knowledge is good, your concepts are good. Suggest some tips and softwares to be used for data science and machine learning projects, or what are the all the programs asked by Sindhuja. Okay, so basically as a beginner you can maybe start with a Jupyter notebook. That is going to be quite user friendly thing for the beginners, because in the Jupyter notebook you can very simply execute the code in a line by line manner. Start with learning Python programming, and as a beginner you can start with you know a little bit of statistics and mathematics. If you are going to learn data science on your own, then that is going to be my suggestion. Otherwise, you can actually enroll into some course so that you can get a proper guideline from end to end how you are supposed to start your journey. Why data science is more important in present time? Huge amount of data is also comes before time ago, but that time it is more important. Data science, I think I have already covered this question, Kunal, why data science is that much important nowadays, so I'm skipping this question. That question. Anjali is asking, do data science need coding skill? Yes, data science is also going to need coding skill, because you are going to basically use Python like or R to build your models, train your model, perform your model validation, and a lot of things before and after building the model. So coding is really required. What kind of business problems there may be? There can be a lot of business problems. So most of the time you are going to work on some sort of predictions. It can be predicting the some sort of classification or type of the objects, like in healthcare, machine learning is used to predict the type of cancer, to predict the type of disease, the level of degeneration of the disease, type of cancers, and in other maybe like retail industry, recommendation models are used where based on the user transaction and purchase, recommendations are made to the users for the new products, for the uh, products the user hasn't bought before. We perform association analysis where, based on the association, similar products are predicted, and accordingly the campaign, the promotion is done. We perform user behavior analysis, user profile analysis to make custom offers to the user. So there are many practical implementation. There are many use cases of data science and machine learning. Then what are the use of sandbox in data science? So sandbox is going to be used as your platform. You are definitely going to need some platform to work on machine learning model development, to load your data, get your data, install the softwares and all. So that is the need of the sandbox. Aditya, uh, what is buenos dias, I have a question. Yes, please go ahead. Machine learning, give an example please. I think I have already updated on that. Does data scientists need to have machine learning language? This field just become famous in past 5 years due to GPUs. Before that, what did the data scientists do? Machine learning is there from quite a long time, Varun. Earlier it was known as, maybe your data mining techniques, but algorithms and everything are there from quite a long time. So it is not the case that machine learning has introduced recently. It has got the new name. Earlier it was known as the data mining techniques. Okay, why Python? I think I have already explained that question in quite detail. Okay, I think initially some of you were facing the problem and you are not able to see my screen. I'm not sure what was the problem at that point in time, but I think you should be able to see my screen now. Only Python, Roshan is asking, only Python is enough to become data scientist. Please tell me. So basically Python, like any one statistical programming language is sufficient, Roshan. So yes, Python is enough as your statistical programming language. But other than that, yes, you are supposed to learn other concepts of statistics, data processing, analytics, descriptive statistics, descriptive analytics and all. Yes, Python is going to be your tool and that is going to be sufficient until unless you have got the specific requirement in any project to use R or some other programming language. Okay. Can I use Keras to prepare the confusion matrix? Aditya, I'm not sure why do you want to do a very simple thing using Keras when you can do it using scikit-learn. Only Python is enough to learn data science. I think I have already answered this question. I'm a non-programmer. Still now, is it suggested to do data science course and switch to this field? A- as such, it is not suggested or recommended. It all depends, Venkatesh, on your interest and your understanding of the concept. So there are many emerging technologies. Data science is definitely one of them, and we have many job openings available in this area. If you find this field interesting, and if you think you are comfortable, you find yourself comfortable to work on all these things, then definitely you can opt for data science. Okay, then Jenna is asking which tool to use for data visualization. I'm Harsha. I have intermediate knowledge of cleaning and performing ETL. What do I need to learn next? So, Harsha, to your question, if you are comfortable with basic ETL stuff, then next thing you need to learn is Python programming, and then followed by that data science, the theoretical concepts of data science gradually. Which tool for data visualization? For data visualization, if you want to learn data visualization using Python, then Matplotlib and Seaborn are the common packages which are used for data visualization using Python. Ashwini is asking, is machine learning mandatory to learn for data science? Yes, because the majority of the project, Ashwini, in machine learning are based on, in data science are based on machine learning. In instead of Python, which other programming language we can prefer? R is there, which is heavily used after Python for data science and machine learning. As I pursue first year experience, is it suggested to do course based on the job? I have completed undergraduate in 2016. I'm quite confused to start my career in data science. I want to know about current hiring goes in the company. Yes, many organizations are hiring, data science intern at fresher level as well. So if you are passing out, I would say for freshers, it should be an ideal, deal to get into data science from the beginning itself, because it is the emerging area rather than you work on some traditional or some old technology. Better you make your decision and get into some emerging areas, and start working in some emerging technologies like data science. I don't have scripting skills, then how this is going to support? So Mohammad Imran, you exactly, you are not supposed to be a pro programmer, but yes, basic concepts of Python programming are required. Gradually you can make yourself comfortable with programming more and more. Data science is like, a 50-50 field, or 50-50 area, where the equal importance is there for theoretical concepts and programming concepts. Okay, so it is not like a core programming areas, okay, or fields where only programming is going to be the whole and soul thing. But yes, apart from programming, theoretical concepts are equally important in data science. What does the use of iLook in data analysis? So iLook is a pandas method with the help of which you can actually locate the records and columns by the index. So that's why it is known as iLook. Independent and dependent variable. Independent variable, Tera, are those which are supposed to given to your machine learning model as input. We also call them features. And dependent variable is something that you want to predict, that you want to forecast, maybe that you don't know. The unknown things are known as dependent variable. Can you explain the test size, Sushant? So test size is nothing but, when you are splitting your data set between training data set and test data set, you are supposed to keep some of the data set ready for the model testing and validation purpose, that we call as test size. So whatever proportion you want to keep for testing, we call it test size, like we use 30% or zero point 0.3 for testing. In a data set, from where to start machine learning? In a data set, from where to start machine learning? So machine learning is going to come second, Sunil. Firstly, you should start with the algorithms. So firstly, you will have to learn the theoretical part of machine learning. Different type of machine learning you should start with. Maybe you can start with regression, classification algorithm, parametric, non-parametric algorithm. So make yourself comfortable with the theory concept of machine learning algorithm first, and then you can actually proceed with the practical implementation. The percentage ratio, I understand. The distribution of it, I don't understand. See, the percentage ratio, Tierra, is Nothing but like if I'm going to have 100 records, only 100 records, and using those 100 records is if I am supposed to perform I'm supposed to implement my machine learning model, then using this percentage ratio, I will decide how many records I will use for model training and how many records I will use for model validation and testing. So basically percentage ratio is that ratio. If I am using zero point 0.3, it means out of 100 record, 30 records will be given for testing and 70 records will be used for model training. Okay. Dear Raman, can you please explain me how to increase the accuracy? So Ramesh is asking how to increase the accuracy in this particular use case. I think Ramesh, so for this particular case study that we have used, you should actually now try to perform the parameter tuning. And here we have mostly one important parameter, which is the K value. So what you can do, you can actually evaluate different values of K, and try to tune that particular parameter first. As the next approach, you can also try some cross validation technique and see if on the given particular training data set, if your model is suffering from underfitting problem, and due to that reason you are getting poor accuracy, if you can change the features, then that also can result into higher accuracy. Maybe this is the classification, binary classification approach, and here the non-parametric model we have used, KNN, is not working that's good. So maybe you can try with some other classification model. These are some primary things you can go ahead with to increase your model accuracy. What is the best software for Python? I'm not sure. What do you mean by best software for Python? I think you mean the IDE. So I generally prefer both, Jupyter Notebook as well as Spider IDE. As a beginner, you can, use any of these two. Spider has got some of the advantages over Jupyter Notebook. It has got, a couple of things extra, like, the console, as well as your variable explorer window and connections, script window. Okay, so that is going to be my first choice. This data science is good career option for MCOM passed out. So economics is actually heavily using data science and machine learning concept. So yes, as a MCOM pass out, you have got the domain knowledge or the business knowledge. Now if you can learn data science, machine learning concept, Python programming, then your domain knowledge can be utilized in that particular area. You can implement data science and machine learning for commerce. How can we choose the right KNN number for my model? So Fatima is asking, ideally this is a sort of hit and trial method, but initially, we should try with some number based on, square root method as well. So some people suggest this rough method, like what if, suppose if you have 100 records present in your training data set, square root of 100 would be 10. You can start with some K value like 10, and then you can a little bit try hit and trial to select some numbers more than 10, less than 10. You can also use some of the parameter tuning or some auto parameter tuning approach. You can use grid search to come up with the optimum value of K. So Roshan, I think I have already answered this question. Only if Python is needed to become data scientist. So along with Python, many other things are required, as I mentioned earlier. How to run line by line in a Spider ID. You can actually use that play button, run button available on the Spider ID, and you can execute the code in line by line manner. Sir, if I use MATLAB instead of Python, would it be easy to operate and use the ML in MATLAB? Yes, Aditya, sorry, Atulya. So that is not a problem. MATLAB has also got great libraries, great functionalities in terms of performing data analytics, visualization, and all. So see, concept-wise, data science is going to remain same. Syntax or implementation wise, there can be some differences when you are using MATLAB or Python or R, but concepts are not going to be changed. How computer vision and data science differ is asked by Imran. So Imran, computer vision is actually a very specific area where we use, sort of image processing with the help of computer vision related packages and libraries, like how camera is going to capture the images or maybe video, and how those images are in turn transformed or translated into frames and the array of the numbers, and then we utilize them as unstructured data in the form of array, numpy array, and make decisions. So computer vision generally is implemented with the help of deep learning concepts, and we have got specific libraries like OpenCV in Python to deal with the computer vision. It is a very specific area. Okay, data science has got a lot of things, other than computer vision. For this course, prior Python knowledge is required. So no, actually in this course, generally we start with a very basic Python programming. So as such, you are not supposed to be comfortable with Python programming. Okay. As such, what is EDA? EDA is the exploratory data analysis. So when we have the data in front of us and we have to start with analyzing that data, we perform both type of analysis. We perform some descriptive analytics, and we also perform some sort of analysis with the help of visualizations and plots and charts. So that is known as the exploratory data analysis when we want to explore the data. Okay, so do I have to be good in math and statistics to start with data science? Yes, statistics and math are very important in data science and machine learning, but actually it is not the case that you are supposed to be very pro or very much comfortable with statistics. Okay, there are limited areas of statistics, probabilities, and mathematics which are heavily used in data science and machine learning. So it is not the case that you are supposed to be good in each and every bit of mathematics, statistics. Himani Tyagi, thanks a lot, Himani, for your very positive comment. Thank you. Thank you, everyone. It was good presentation and often needs handsome experience. Hey, Venu, thanks. Okay, so friends, I'm actually skipping some questions because we are already, beyond the time. So I'm really sorry about that if I'm not able to cover all of your questions. Okay, so Dinesh Kumar is asking, basically I like to learn machine learning. So Dinesh Kumar, machine learning is not different than data science. Basically, if you are learning machine learning, gradually you will learn data science as well. Yes, as a your starting point, you can actually start with machine learning, and at your initial level, as your initial career, and during your initial career, machine learning can be very helpful to beg you a job, okay, as a machine learning engineer, as a Python developer, maybe in a data science project. What is the scope of data science? What you recommend about switching from .NET to data science? .NET has become quite an old technology. I will not directly recommend you to switch from .NET to data science, but maybe you can, if you still want to be in web development or UI development. A lot of latest new and emerging technologies are there uh, for application development, so maybe you can switch to those technology if you do not want to change your domain or area. But yes, data science is something which is quite hot nowadays. So if you are interested in machine learning and data analytics, then yes, data science is one option for you. The scope of data science is quite good because in India specifically, many corporate Indian corporate houses, including all the banks, insurance companies, manufacturing houses, they all are directly recruiting data analysts, data scientists, machine learning engineer. So yes, data science is has got very good scope in India. Is data science related to data engineering? Asked by Kahindi. I would say data engineering is a part of data science. So as I mentioned earlier, so yes, data engineering is a particular phase that we work on while working on a data science project? As you said, there are three types, so I have just included one type of data in your session. Aditya, I'm not sure if that was a question or comment, but I think you are not asking something as such. What is the difference between machine learning and deep learning? Machine learning is going to mainly talk about the structured data. Most of the time the structured data is used as input for all the machine learning approaches. When we talk about deep learning is mostly utilized for processing and using unstructured data like images, videos and audios. That is the primary difference between machine learning and deep learning use case. Okay, and on the other side, from the implementation point of view, machine learning are always going to be dependent or also always going to be based on certain algorithms, some statistical algorithms or models. On the other side, deep learning are you know based on the neural network concept. Okay, how does a neuron, how the network of neuron of a human brain learns the thing in the very similar way, we it is based on the artificial neural network concept. Okay, so friends, I think we are already beyond the time, so I might not be able to, answer the remaining questions. So thank you everyone for, participating in this particular webinar. I hope you all found this interesting. Thank you all for all the great and positive comments, and looking forward to interact with you again in future. So thank you everyone, and here I'm going to wind up this webinar. Thank you all. Thank you everyone.